My last video, I showed you how to find the resistance by measuring values in Tinkercad of an input circuit on your Arduino, which was an ultrasonic rangefinder. And since viewing that video, a few of you have asked me some questions about other components, such as LEDs, push buttons, and potentiometers. I'm going to go through a few of these because some of the ways in which these different components behave can be very confounding, and so I just want to show you a few strategies. What's going to be helpful when you start your calculations is to just open up a brand new sketch. That may seem daunting, but you're not going to have to rewire everything that you had on that exact same board. I would label the sketch circuit calculations, and maybe with you and your partner's initials. And then what I would do is take out all of the components that you're going to need to test in each of your individual input and output circuits, and just place them right here by searching and then dragging them just here to the tabletop side, kind of next to the breadboard and the Arduino. Once you've done that, you'll build each individual circuit and test it. This will eliminate, just by wiring it directly into 5 volts, any need for coding each component, and that will make your job a little less complicated. So let's first start with an LED. Now for an LED, I will say we're not going to be able to take the resistance of it using an ohmmeter. So we're just going to wire it onto the board in this fashion. Make sure that you have a typical Arduino setup, making sure that if you're going to utilize both sides of the breadboard, that you have the positive and negative terminals connecting to both sides over the bridge. Here, this is our 220 ohm resistor that we're going to use to drop from the negative side, right here. And then instead of, typically what we would do when we wire this is just go from this side of the LED to a positive. And then when we start the simulation, it should shine like this. But because we're going to use this ammeter, we're actually going to stop the simulation, delete this wire, and insert this. And remember that we need the positive side of this to go into the positive terminal, and then we're going to start the simulation. So what you'll find here is 13.5 milliamps. And so we're just going to go and put that value over here. So our voltage is 5 volts, and our current is 13.5 milliamps, which is going to be 0.0135 amps. And we're going to do a calculation V divided by I equals R, and then divide 5 volts by 0.0135 amps. All right, and when we do that, we'll get a value of 370.37 ohms. And then if we were to subtract out, so if we were subtracting out the resistor to get the value of just the LED in this circuit and value resistance, we would just take the 370 and subtract out the 220. And get 150.37 ohms. Now, the calculated value for that entire part of the circuit is 370.37 ohms. Now, the sad part is that we really can't measure this because LEDs behave in quite a different fashion than the other circuit components that we've been looking at. So let me just show you really quickly what happens when we go forth and try to measure this. If I put this to the positive, and then this negative, and then I select resistance, and then start, it freaks out. And so we're not able, in general, like in real life, to use an ohmmeter to measure the resistance of an LED And so we have to depend on the calculations that we've done here. So let's do a couple more of these. So the next thing that I want to look at is the push button. And so if we wire the push button without having it drop into a pin, we would put it like this. We would then take this 10 kilo ohm resistor, drop it into the negative terminal from the same row that this terminates in, and then obviously the positive would go to 5 volts. Again, we're going to want a multimeter out here, and we're going to want to delete this wire and take this positive to the positive terminal here, and the negative to this area here. Now when we start the simulation, what you'll notice, all right, oops, sorry, I have this in voltage. So if I put this to amperage, which is what we need, you'll notice that there are 0 amps. And if you think about it, that makes a ton of sense because there are clearly 0 amps because the button isn't pushed. There's no current flowing through the circuit. Now when I push, current is allowed to flow at actually 500 microamps. And so when we have 500 microamps, basically what that means is that's 500 times 10 to the negative 6 amps. And so if we were to do another calculation, so I'll come over here and let's call this the push button. And we're going to again use V over I equals R. The voltage that's dropped across it is still 5 volts. The current is 500 microamps. And that would be 0.0005 amps. And so 5 divided by 5 volts divided by 0.0005 amps gives you what you might expect, which is 10,000 ohms. And now you're probably looking at this thinking, okay, well clearly that means because we have a push button in series with a 10 kilo ohm resistor, that means the resistor, oh I'm sorry, carries basically all the voltage is dropped across the resistor there, which means that with a 10 kilo ohm resistor, the resistance of the push button is 0. It's not a resistive component. And we can actually go in and check that. So to check it, sorry, I need to stop the simulation, take the push button out. I would grab this, place it on this terminal, place it on this terminal. I would make sure that, this is set to resistance, start the simulation. And what we'd notice is that, move this down here. What we notice is that's 0 ohms for that push button. If you wanted to further measure and just make sure, right, we could take this resistor out, we could put it up in series here and connect it, start the simulation, and we got 10 kilo ohms. So very clearly that aspect of the circuit is just 10 kilo ohms. Now the last thing that I'll show you is the potentiometer. And so let me get rid of the push button. Oops, I got rid of the wrong thing. Let me get rid of the push button and just get this multimeter out here. And I'll put the potentiometer here. And again, we're just going to wire into 5 volts and ground. So here I'll wire in the ground and 5 volts. Again, just because we're using this, I'm going to make sure this is set to amperage. And then I'm going to take the negative and go into the negative rail. Sorry. Escape. I'm going to take the positive and I'm just going to go in the same row here. And if you click on this, you'll actually see what the resistance is that they're giving it. and I believe that this is the resistance that all of our potentiometers has. But if we want to just do the measurement and figure this out for ourselves, we can. So again, if we're doing a potentiometer, we would do V equals I over R. We would come in here again, we'd put the V as 5 volts. And for the current, we would take the measurement, again, just checking that it's amperage. I'd start the simulation. All right, and again, we have 20 microamps. And that is right, so that would be 4 zeros there. And that would be how many amps it is, because you're moving the decimal place over 6. If it were talking micro, for milli it's 3. And then we would do V 5 volts over 0.00002 amps. And just confirming that value gets us 250,000 ohms, or 250 kilo ohms. And so let's do that measurement again over here. I'll stop the simulation. I'll take the potentiometer and drag it out. And this is just kind of an annoying process to click these wires. All right, I switch it to resistance, and then I'm going to start the simulation. And we get 250,000 ohms, despite the Tinkercad simulation actually telling us that at the beginning. We've now experimentally found this value. And I've been putting these in the calculated values, but they're also the measured ones, with the exception of the LED, which we were unable to get a measured value for. And so you can just put NA for anything that behaves in the same manner as an LED on your circuit. To calculate the total resistance, we're sort of thinking of this as a circuit in which you're going to have all of the components running at the same time. And so in truth, we're really asking you to take the voltage dropped across each thing, which is 5 volts, and then divide that by that total current that is running through the circuit at once. And so you can just perform an Ohm's law calculation to get what the total resistance is, rather than adding up all of those resistances. And again, for power, you've done all of the measurements, and so you're simply just doing a calculation here. And the measured value is really just going to be the same thing. I believe that that's all, and I hope that that was helpful just to give you a little bit more clarification. And if there are any other components that you're having trouble measuring that you would like some assistance on, please let me know. But the first thing that you should really do is just build each component going from the positive to the negative rail, and then do that measurement for each separately. Thank you so much, and I hope that was helpful.